All right, let's talk about chapter 8, which is addition reactions in alkenes. So we're going to talk a lot about alkenes in this chapter, and we're going to learn a lot of exciting reactions that we call addition reactions. This is one of my favorite chapters in the entire year of organic chemistry. So, introduction to addition reactions. So it says here that addition is the opposite of elimination. And if you remember in chapter 7, we spent a lot of time talking about both E2 and E1 reactions. And those were reactions where we eliminated something from a molecule in order to make an alkene. But what we're going to do in chapter 8 is we're going to look at a lot of reactions where we take an alkene and we use the functional group, that alkene, and we're going to add something to it. So it says here the addition of X and Y, and those can vary, and we're going to look at some examples of what those could be in table 8.1. But it says here that the carbon-carbon pi bond is converted to two new sigma bonds. And you might remember from your from general chemistry and also from the beginning of organic chemistry that a pi bond is made by the sideways overlap of two p orbitals, and a pi bond is in fact weaker than a sigma bond, and that kind of gives you a clue as to why an alkene is so reactive. Anyhow, all these different addition reactions that we're going to look at in this chapter are summarized, or some of them are, at least are summarized in table 8.1, and they have all kinds of interesting names. So I thought we would take a look at them first. So the first one here is called hydrogenation, and the name describes what's going on. So you're adding a hydrogen and you're also adding a halogen. And the halogens that we're going to look at are going to be chlorine, bromine, and iodine. So that means we're going to add HCl, HBr, or HI to the alkene. The next one is hydration. I think this one's pretty intuitive because hydration is just the process of adding water. So that means we're going to add a proton and a hydroxyl. So that's kind of neat because we're converting an alkene into an alcohol. The next one is a hydrogenation reaction. So this is literally just adding a hydrogen molecule, an H2 molecule, to our alkene. And if you've ever heard of things like hydrogenated vegetable oils or partially hydrogenated fats, you might connect the dots here and realize that that's related to the mechanism or the reaction of hydrogenation, and we'll talk about that in detail. The next one is halogenation, so that's simply adding a halogen, and you might remember that the halogens are diatomic molecules like fluorine, chlorine, bromine, and iodine. And for halogenation, we're going to talk about two specific types of halogenation, so adding Cl2 or Br2, so either chlorine or bromine to a molecule. And so then we're going to take a look at what's called halohydrin formation. So this one here, a halohydrin. So that's something you probably haven't heard of before, but basically that's adding a halogen and a hydroxyl to the alkene. So that's kind of a unique reaction. And the last one is a fun one, is what we call dihydroxylation. So that's adding two hydroxyl groups to the alkene to form what we call a diol. So this molecule here, we would call that a diol. Anyhow, really exciting reactions and really fun to study all these different kinds of reactions that can occur on an alkene. So all of these different reactions that are observed for alkenes enable them to be used as synthetic precursors for lots of different reactions, and it enables you to make a wide variety of functional groups with them. And the versatility of alkenes can be directly attributed to the reactivity of pi bonds, which can function either as a weak base or as a nucleophile. So it says, or it shows here in the first example, that the pi bond can be readily protonated. And here I just have a curved arrow showing that the pi bond is attacking the proton, and I end up forming a carbocationic species. And in the second example here, it shows the pi bond behaving as a nucleophile, so the pi bond is attacking an electrophilic center. And we're going to look at many examples of both of these types of mechanisms throughout this entire chapter. So a lot to look forward to in Chapter 8 in organic chemistry.